What if cyber attack isn't stealing your data, but destroying your physical reality?
I was a chief information officer at one of the U.S. Department of Energy national laboratories.
Stuxnet?
Towards basically physical impact just using cyber.
It was a very big deal.
And this can be a mix of different protocols. So in this one, we've got Modbus TCP, Modbus RTU, we got 420 milliamp.
Like, can our nuclear station be manipulated from Russia or from...
Someone lit the flame and then lost control of it. The early industrial control systems weren't built with cybersecurity in mind.
Zero Trust Podcast is a show at the intersection of cybersecurity, business, and AI. Hosted by experts in the field, Art and Oli, the podcast unpacks the latest threats, trends, and innovations shaping the digital security. Zero Trust Podcast brings raw insights, expert interviews, and thought-provoking discussions to help businesses and individuals navigate an increasingly hostile cyber world. Whether you're a security professional, tech, or business leader, this is your go-to source for unfiltered cybersecurity intelligence. And remember, never trust, always verify.
Okay, here's the thing. This episode should have been a podcast. But because of the discussions that were so fruitful, so deep, so interesting, and so engaging, and so long, we decided to make a documentary out of it. Grab a cup of coffee and enjoy. Our world runs on quiet rhythms. The hum of power plants, the rush of clean water, the whistle of trains. We check computer screens and assume everything is fine, but there is a gap between what the screen says and what the wires carry. In that gap, attackers can hide. Cybersecurity is not just about protecting files on a laptop. It's about keeping the lights on, keeping the water clean, and making sure trains arrive on time. In 2010, a digital worm called Stuxnet changed the game. It didn't just steal information, it broke real machines in a nuclear plant while telling the human operators that nothing was wrong. It showed that if you control the wires, you can make the computer lie. This episode dives into the hidden layers of operational technology, the sensors and controllers that run our factories and utilities. Through clear explanations, we'll show how outdated signal lines can conceal cyber attacks and knock critical systems offline, leading to real-world shutdowns and blackouts.
Nothing like starting something off in a bomb shelter. So
Yeah, we just came from the bomb shelter and now we look at this beautiful stand which you have prepared for ICS experts, ICS security experts. Guide us through this stuff.
So what was nice is when you came in, you recognized the Purdue model from this right away.
For those who are not familiar with the Purdue Model, it's time. The Purdue Model is a reference architecture that explains how industrial environments are structured, from physical machines on the factory floor to business systems and the internet. At the very bottom is level 0, the physical process itself. This is where the real world lives. Motors spin, valves open and close, voltage changes, current flows. Nothing here is digital, it's pure physics. Levels 1 and 2 are where sensing and control come together. Sensors read what's happening in the process, temperature, pressure, voltage, and controllers like PLCs decide what to do next. For example, if a sensor detects an overload, the controller can stop the process or trigger an alarm. Levels 2 and 3 focus on operational visibility. This is where operators and engineers monitor systems, view dashboards, analyze trends, and understand how the process behaves over time. HMIs, SCADA systems, and local monitoring servers. And at the top is the level number 4, the business and IT layer. This includes enterprise systems, reporting, remote access, and connections to corporate IT or to the cloud. And surely, this is also the layer where cybersecurity risks tap into the industrial environments. The Purdue model helps teams to understand where each system belongs, how the data flows between different layers, and what most importantly, what security boundaries should exist and at which level. Knowing that, everything which Michael and Richard tells next becomes much more clear.
So what we wanted to do here is create an environment where we could really start to explain and teach people what's actually happening in an industrial control environment. So most people's perspective today is it's all, Ethernet based. It's all, on the internet. But the reality is the majority of your critical infrastructure runs on communications that aren't Ethernet.
Exactly.
And getting that point across to folks, we really needed to come up with something that we could visualize for them.
So today we have Richard Robinson, CEO of Cynalytica, as our guest. We're pleased to meet you. It's a big pleasure to have you here today.
It's a big pleasure to be here.
Thank you. And Richard is the CEO of Cynalytica, which is the company pioneering in the area of visibility and defense for critical infrastructure, developing tools, mechanisms, and technologies which would help and which are already helping to secure critical infrastructure. Thank you for being with us today.
Thank you.
But it's not the only project that Richard runs. You have other companies, right?
Yeah, I have another company called BaseVox. It's been, kind of quiet stealth mode. We're working on developing malware detection tools. And so we just finished kind of a milestone with our partner here on giving a PhD dissertation on the technology.
Congrats.
So we're very excited about that.
Cool. So you're a serial entrepreneur now.
Can you give us a short overview what the Cynalytica does, how it started, and what is the mission of the company?
Absolutely. So started Cynalytica around 2017. Prior to that, I was a chief information officer at one of the U.S. Department of Energy National Laboratories. I was there at the time that Stuxnet came out. And, prior to getting into IT and being the CIO, I was, academically educated in manufacturing engineering and industrial automation systems.
It's your brother as well, right?
As my brother Michael too. So his focus was initially more in agricultural engineering and technology. So we've got a pretty broad spread from the.
You already have some ideas how to pivot your business later on, right?
Exactly. So when Stuxnet came out, also being at a DOE laboratory, it was a very big deal. And again, background being in manufacturing engineering and industrial automation, right away, the warning light was going off that we have a problem.
Information for the audience who might not be aware of Stuxnet.
It's a first unprecedented attack against ICS in history. And I think the main goal was to target nuclear enrichment plants in Iran, right? But then it exposed outside Iran as well, and other countries, including United States, let's say, felt this potential technological influence, let's say.
Right. So because this event, like maybe nobody was really thinking about, like, can our nuclear station be manipulated from Russia or from somewhere else, right? And now when it became reality, everyone starts to be
I think Stuxnet opened this era of understanding that some state actor could influence heavily using only cyberspace, well, mostly only cyberspace, influence and bring the situation towards basically physical impact just using cyber.
So then Stuxnet happened, and then what was next?
So, it's one of those philosophies too. I say, someone lit the flame and then lost control of it.
Because one of the things Stuxnet would do was attack the industrial control environments, but in a way that there was no visibility to those types of attacks because it would be over serial or analog communications. So if you weren't monitoring those things, you were susceptible to those types of attacks that were not visible. So we actually started, the biggest area, at least from the folks that we had worked with, was around serial communications.
Okay.
So the challenge with serial communications, it's not like internet communications. You actually have to put something on the communication bus to monitor that. And you didn't want to develop something that then became a new threat vector or introduced, another operational threat through failure or anything else.
Most people imagine that everything in a modern plant is connected to the internet. In reality, deep inside the factory, the familiar Ethernet network cables end. Machines and sensors still talk over gray serial wires and analog signals invented half a century ago. You can't install antivirus software on these wires. For years, nobody bothered to listen to them, which allowed attacks like Stuxnet to ride on the serial pulses and remain unseen. To solve this, Richard Robinson and his team made a simple listening clip that fits around the wire without stopping the current. They call it Serial Guard.
There was no technology to safely and securely monitor those communications. So at the time, the only thing to do was to introduce some type of, they'll call it a bump in the wire to get that communication. But that introduced operational risk, potentially a new threat vector. So
because you're actually in line.
You're in line.
If you're compromised, you would be another point of threat and point of entry for adversaries.
Exactly. So, the prevailing thought was, this is just going to introduce more problems. So we're going to kind of pretend that the issue isn't there.
That we are a security company, so that is why we're secure. So nobody need to
Exactly.
to worry about that.
We worked with the U.S. government, Department of Energy, Department of Defense to develop the serial guard, which was that first platform that lets the operator put something on the communication bus that is passive and fail-safe, so it doesn't introduce any threat vector.
How is possible?
And now it's possible, so now we gave you, new visibility, but, we wanted to go further than that. So the device is actually an intelligent device. It will frame the communication based on the industrial control protocol.
Okay.
It will encrypt it, and then it brings it back to our analytics engine for decryption, as well as deep packet inspection. We had some other stuff around it that we call contextualization. So it makes it easier for an operator to understand what's happening without being a protocol expert in Modbus or BACnet or, any of those industrial control protocols. So that's where we started. At the serial level, we started working in the commercial oil and gas industry. We were getting feedback from a customer that they were seeing a particular type of adversary doing an exploit.
Even that was not enough. Pipeline operators needed to collect data from sites with no wired network, so the team built OT NetGuard, a system that reads data from different types of wires and sends it back over signals like 4G or 5G. It uses one-way communication, so nothing can be sent back to the machine.
Yeah, so we were doing the serial stuff with them, and then they got back and said, hey, we're seeing an adversary trying to attack a particular type of equipment in pipeline operations, but it was on the 420 milliamp signal.
Okay.
So they said it would be great if you guys could develop a technology that was, the approach was the same for serial communications, for analog communications. So we actually received a little bit of funding from the state of Virginia to develop the ability to do that. And so these are our 420 milliamp sensors. But at that same time, we wanted to revisit just kind of the whole architecture of stuff. So when we started the company, we actually had the ability to monitor your IP industrial control communications, but you had a lot of companies that had raised a ton of
Which
money in
are
that.
always isolated, right?
So I said, let's not go into that market right away because we have a market that we're very differentiated in. But at that time we just said, okay, kind of the gloves are off. So we will develop a new architecture that does IP, serial, and analog, but does it in a more efficient way. So what we didn't want to do is give, operators where they had to buy 80 different parts. So we re-architected the platform. We call it OT NetGuard. The idea is to simplify the hardware for folks where you literally just have to swap out the physical layer module. So the other challenge that the pipeline operators had was there were a lot of environments where they didn't have networks. So there's no network drop, but they still needed that data.
Okay.
So we gave them the ability to use cellular, so LTE, 4G, 5G, to get those communications out of those environments.
Which is crazy scary, I guess, for CIS. So LTE on my factory. God,
Well,
no, please.
so that's kind of the beauty of this is you can get that data out of that environment without introducing any threat. It's literally just kind of like sucking it out and taking it
why?
over.
Because it's fail safe first of all,
It's passive and fails.
and it's passive.
Yeah.
So it's one-way communication now.
It's one way. It's literally just pulling it out of there. We have had a lot of folks ask us, well, can you make it active? And we're all, we don't want to do that. What we'll do is we'll inform an active system that something's happening. So if you want to, you detect a threat or something and you want to do microsegmentation, you can do that quickly, but you can still see what's happening in that environment, even though you're disconnected from whatever that network was.
So in other words, you have a backend, a server, which basically gets all this context, correlates it, and then from this server, potentially you could send any type of signal back to the system, but via different route.
This matters because most cyber tools watch only the higher layers, the computer networks. The real truth lives lower down in the simple signals that turn motors and pumps on and off. If you don't look that directly, you're trusting numbers stored in memory that an attacker can change.
Yeah, exactly.
Correct.
Exactly.
Correct. So why this is so important is most of the cybersecurity tools that are out there are sitting at this layer 3, layer 2, right? They're monitoring the data that's coming from these levels. So what happens is the real data and the real variables, what's happening, and the truth is coming into this controller at level 1.
Okay.
So this analog data, this serial data that's communicating to the VFDs over Modbus, over IEC 101, over DNP3, BACnet, all those serial protocols are being aggregated into this controller. But they're being stored in a memory address in this controller. So that memory address is always suspect. Is that really the value that's been communicated? Then this value at level 1 is being communicated over maybe another serial protocol. It could be an IP protocol back to a SCADA system. And then that SCADA system is going to a data historian or somewhere else, where we're only monitoring today with those traditional tools at this level. We're making an assumption that that's the true data.
Right.
So if your device is compromised,
You don't know.
you don't know.
And you have the whole chain, right?
So now we introduce our sensors at these levels. So now we can tell you what's really happening.
Very smart.
And then with the analytics engine, we can then evaluate that and correlate it as to, what you're seeing and what's really happening. So going back to that Stuxnet type of event, you've got a PLC that's compromised. It's telling you everything's fine. Well, everything is not fine and you can't see it. And that's exactly, what we want to be able to do is give you that visibility as to what's physically happening in your environment.
So you truly now have that forensic quality data at your fingertips.
And it's the raw data which is stored on the boxes, right?
Correct.
How long it took you to develop the entire system?
Still doing it.
The team built a small water plant demo. They showed how an attacker can secretly change the flow without the operator noticing. On the screen, everything looks calm, but if you listen to the pump, you hear it working harder and harder.
Shall we do the attack?
Yeah, do a Stuxnet type.
Yeah, so I turned off the motors because they're loud.
Are you reset on Siren?
You turned it off using legitimate controls, or you hacked it?
No. So in this scenario, what's going to happen is we're going to write new values to the outflow.
Okay.
But you're not going to see it on the HMI. Okay. But you'll see over here in the analytics engine, it's a critical alert. So you'll see that critical alert. Every packet that we detect that there's something not right, we're alerting.
And this logic something being not right, it's something which is hard-coded by you, or it's
So it's in our query language that's in the analytics engine. But so your typical approach is we come in and we baseline what's happening in your network. So we're going to see what function codes are communicating between your devices. We're going to know what are the control devices, what are the command and the control devices. So we're going to be able to document that. Then we can go in and put control lists.
okay.
So the two alerts that you're going to see, one is an unknown function code or an unauthorized function code. So the attacker's coming in. The attacker doesn't know what our network is. So the attacker is most likely going to use a command or come on as an address that I haven't buttoned down in my system.
Okay.
And it's going to communicate, and we're going to catch it. We're just going to alert on that from a control.
So you have the total asset inventory in the system, and you compare it to anything which is fault.
And so there's two parts to that. One is, hey, I've seen something that I shouldn't see from a command. The other one is, hey, these values don't match. And so, kind of going back to the Stuxnet.
Inflow and outflow, right?
The outflow it's a set point from the command center. So it's not going to change.
Yeah.
Right? So the minute that it does change, that alerts us that it shouldn't have changed. It's changed. Investigate.
Yeah. So going back to the Stuxnet type of environment, you've got a compromised controller. They're telling you everything's running fine. And, as the centrifuges, they were spinning them up, spinning them down, spinning them up, spinning them down, destroying them. They had no visibility.
So let's go ahead. So now we're running just fine. And we're going to go ahead and initiate. So now here's the outflow on the HMI.
Okay.
See what's happening to the motor?
And you can see our alerts are just cranking up right up there.
So this is seeing packets that are coming across that are not what they should be and functions that they should not be.
Okay.
So we're getting two alerts. One is the unknown function code. So an unauthorized function code because the attack doesn't know, and it's using a function code that we don't allow in our control system. And then the data mismatch is that the the speed is changing.
By looking at the electrical poles on the wire, the most basic signal, you see the attack immediately. A hacker can fake software values, but they cannot change the laws of physics.
Right. And that's kind of a key philosophy that, we started the company and we built the technology from. We accept that there's diminishing returns. We accept that, you're going to have an adversary in critical infrastructure. The reality is the adversary is probably already in your network.
Yeah.
We see it time and time again. So the approach was, I can't fix those things, so let me watch as much as is actually happening in my environment as I can. Let me understand and learn that, and learn to identify quickly or detect when I have something that's compromised or not operating correctly. And that has really very little to do with, access controls, firewalls. Our assumption is they got through.
Yeah.
Now what? And sometimes, so going back to Stuxnet, which is kind of an interesting piece, because Stuxnet, when it would get into the environment, was looking for a particular target, particular controller. If it did not find that target, it just kind of died, didn't do anything, which introduces kind of a new dynamic for folks that if they just see something that says, oh, I have malware, especially in industrial operations, it's like, I got to shut down maybe. But you may have, like in the Stuxnet case, maybe you didn't have that particular controller.
Yeah.
So I don't have to shut anything down, but I do want to monitor activities that might be indicative of that type of thing. And so again, that was another thing that we wanted to be able to address is you may have an adversary in your network. You may not be able to get them out in a cost-effective way. So what would be your best position? And that would be to monitor anything and everything that you can to have that, we call it full spectrum situational awareness.
What do you think about deception technologies in this realm? Is it practically doable to have like the copy of ICS controllers? For instance, Stuxnet, it was targeting some particular, Modbus enabled box, right? And knowing that there is an epidemic of Stuxnet right now, because you should have your threat intelligence done, your homework about threat intelligence done, and you actually, we see that this is what's being currently active, so we put a deception box, which would say that, I'm right. The one you look for, Stuxnet. Do you think it's a good approach for ICS environments?
So I think historically, it's been demonstrated that proficient actors know that it's a honeypot.
Okay.
So you have to be really, really clever. So the idea, like I said, you're raising bar, you're just putting other tools to make it complicated for folks, but then you've got that subset of folks that are extremely good at this. And so, putting up a honeypot is not going to influence them at all. They're going to see it right away. So, it's always that, trade-off space, as we like to say.
Sure. It is. Security is all about trade-offs, actually. Yeah, right. Okay. So I want to ask how, generally speaking, ICS security is different from conventional cybersecurity. So what is the key, I would say, top 3 items which is on your list?
As far as the difference?
Yep.
Resources, there's a big difference. I think you've got more folks available to you in the IT industry with the specific, type of skills that you would want to have. Okay. I think in OT, there's a stark contrast.
Yeah.
So you don't see that as much. The primary purpose of someone in OT versus IT is OT is going to be about safety and security. That may not necessarily be the primary consideration, and priority for someone on IT. I think another big challenge is really funding and resources in light of the current environments. So I think IT gets well funded. I think OT security is sorely underfunded. And again, I think that's because not only people's understanding of their environments, controversial subject number 1, I do believe that in general, the ICS cybersecurity vendors in industry have done a really good job at convincing folks that problems don't exist in there, and have confused the market considerably. So, when we go out and talk to folks, and we hear it every time, they'll say, well, so-and-so told us I either didn't need to do that or it couldn't be done. And, we are a small company. We're not, we
Usual suspect in terms of objections.
we've been built entirely different. We haven't raised any, external capital. We're not looking for, to do an IPO. We're really just trying to build a technology that helps protect, folks. And so, for a lot of these other companies, they've got shareholders. And so there's this drive for, market. And like I said, I think they're not telling customers the complete story.
So you say that IT enablement companies, comparing to cyber companies, I mean the producers of the tools, the vendors, they promote that there is not so many security issues.
Correct.
Right?
Yep.
Comparing to what we say, guys, come on, we use the 100 years old technology basically, or 50 years old technology, right? And the people who invented it, they probably not exist anymore. So
and one of the reasons is because there is no clear way how to handle this security threats, right? As you mentioned, because there is no yet developed very common technology that's being used for that. And this is probably what you're trying to do to build a technology that will allow people to tackle these threats, not only threats, but also maybe have some other additional effects on their business, as you mentioned earlier, right?
Yeah, correct.
Many executives still think that cybersecurity is just an expense. In truth, the same information that exposes hackers can also tell you when a pump is about to break, where you are wasting energy, and how to plan maintenance. Using this data saves money and keeps the plant running smoothly. Richard and his team call this proof of value projects. They work with utilities and water companies to show that the data they already collect can pay for itself. When you talk about dollars and savings, you don't just speak to the security team, you speak to the operations officer and the finance officer.
What we can do is we can demonstrate return on investment and business value through the analytics. Sure. Whether it's evaluating your processes, predictive maintenance, prescriptive maintenance, all of those type of things. So that's really the push that we're on right now, is demonstrating what we call POVs, proof of value. So working with utilities, water operators, and saying, you're getting this data now, let's turn it into something where I can tell you where you're going to get your money back. If I can do that, now I'm not talking to the CISO or the CIO anymore. Not that I have any
no issues with them, but
but now I'm talking to the chief operations officer, the CFO, where we're saying, hey, you're going to see a return on your investment through the capability, and as a derivative benefit, you now have better cybersecurity.
Totally makes sense.
And so it's all there. It's really, just now starting to demonstrate it and dial it in for different industries. So what you see here is actually one of the communication packets. Which one is this?
This is a Modbus RTU packet.
Modbus RTU.
So up at the top, it reads the holding registers. So it's a request. So it wants to start at 40,201, and it's going to read, I think, 5 variables. So this is the request. And then I can just walk down the line now and see what happens. And here's the response.
Yeah,
so
it's 5.
Yep.
Yeah, so these will be different values for different functions.
Correct. And this is the actual payload in that data, and we do store the actual hexadecimal values. And then the packet metadata is the extra contextualization that we add from what our sensor's able to add.
From another level, yeah?
You got it.
Yeah. So one of the things we do is we'll actually time the information as it's going across. So one of the areas that will enable us to do is also fingerprint communications. So understand how devices talk to each other, and is that the device? Is that the communication that should be in there? Which gives you now another level of kind of visibility and understanding of what's there, who's there, what are they doing, what are they saying?
Exactly. This is a Profibus P packet.
And Profibus is what level?
So Profibus is down at level 0 for us. Well, level 1 technically. It's a level 0 device, but it's sitting at level 1. Okay. Communicating to the controller in level 1.
We are entering a new generation of industry where raw data from machines feed artificial intelligence that can predict problems before they happen. At the same time, AI gives attackers new tools, malware that changes itself, fake voices that trick people, and supply chain attacks that spread quickly. To keep up, companies need to adopt ideas like zero trust, use stronger encryption, and buy hardware built with security in mind.
In industrial control environments, we're getting a lot of telemetry data, physical control data that has extreme value to the business, whether it's from its operations or its maintenance. And I don't believe that the industry writ large has kind of identified that and embraced that if we move faster at safely and securely getting that data from systems and start leveraging machine learning and AI, we can start driving business values and return on investments from our data. That was, a couple years ago, impossible, if not exceedingly challenging. And again, one of the areas that we wanted to address up front. Let's get the data out safely, securely. Let's get it normalized and curated to where it doesn't cost you $10 million just to get the data into the database for analytics. And then let's now start using machine learning and AI to drive that value, whether it's through predictive maintenance, operation. There's just an unlimited amount of things that you can do with that data. So now that we're able to more or less mine and curate that data, we're now able to get it into AI frameworks, which now opens up a whole new opportunity of things that we can do. And so now we're purely, into the analytics space. And with how rapidly AI and AI technologies and capabilities are iterating, our perspective too is if you're not on the boat now, you may be waving from the shore.
Yeah, many American investors are currently and they have huge concern generally on the AI topic in terms of power supply, data centers, and how to host the future, basically, the future technologies. And suddenly, lots of stakeholders and think tanks start to understand that, okay, guys, the tempo we have, the pace with which we could build, and the pace of AI development is so different.
Right.
We need to do something with that.
Right.
So, it's a very promising and definitely demandable space to work in. Congratulations.
I think AI poses so many challenges that I don't think we've really come to terms with.
Yep.
I was fortunate when I went to school. I had two great professors at MIT, Eric Braunfelsen and Andrew McAfee, who really talked about, 20 years ago about, the impact of AI. And, they were very positive, on that. I always took the dystopian view of this.
Because you have cybersecurity hat on.
Maybe it's still coming. We don't know.
Well, I always have this need to run something to its illogical conclusion, whether it's positive or negative. And so, with AI, it just poses, displacement of workers. And as as AI starts to integrate with other types of technologies like robotics, you can clearly see a disintermediation of the need for people to do things. And that's pretty massive, So how are you going to do that? Then you actually, you add the power type of concerns, the energy type of concerns. So, and I think, like you said earlier, it's moving so fast, and we still haven't got our heads wrapped around the problem that, what are these unintended consequences going to be, and how quickly are they going to be on us?
Yeah, and from even financial standpoint, if we're talking about AI power issue, so far there is no scarcity of resources in a sense, right? So we have sufficient amount of power, but once the demand be growing, it's already growing, and again, the paces of our ability to produce more energy and the paces of technology being developed are very different, and technology is quicker. Then in 5 maximum years, probably the electricity would cost enormous amount of money, or the technology would stop being built. But it's in the free world, it's impossible because there are businessmen who wants to build it, right?
Yeah, absolutely.
So maybe we'll just have more nuclear stations.
Yeah, but it's not like that, right? You can't do it tomorrow.
So coming from a DOE laboratory, there are technologies that can solve the problem. But to your point, how quickly do they get developed? What is the interest to invest in them? And maybe that paradigm has changed the last couple of years as, maybe investors are seeing, yes, this is a real problem. This is an opportunity. Let's accelerate some of these technologies.
Yeah. There is a think tank in US, Rear Admiral Mike Hewitt, who works in this field. Maybe you have heard about him in the field of affordable nuclear plants, which are kind of small, and the ideal situation, they would be available for every household, so you could have it near your garage,
like a bottle,
like something very small, which doesn't require too much of maintenance, but could produce and empower the entire street, let's say. And I see that he's not alone, and there are a lot of interest in this approach. And actually, the Rolls-Royce in UK, they are also I think they even have something like a prototype to, but yeah, it's completely different story. It then becomes an ICS as well, by the way.
It does, absolutely.
Yeah.
So touching the industries, which industries are most interesting for Cynalytica? Nuclear, agriculture, water, energy?
So there's two thoughts. One, what's interesting to me. Two, who's actually interested in us and the technology.
Where do you?
Yeah, exactly. Where do we meet? So at a high level, our attitude is wherever you have industrial control systems where safety and security are concerned, that's our customer. That's who we want to talk to, and that's just about every company that you can think of.
And when we say safety and security, we mainly say about adversaries and attackers attacking your system, or something else?
Our philosophy was, safety, security in control environments. So if you've got, industrial controllers, and any of that process that you are doing may create harm to folks or safety issues, that's really who we want to be talking to. In defense, they just wanted it for situational awareness. And I'm sure, safety and security is part of their operations, but that's not necessarily why they're talking to us. On the commercial space, that changes. So the folks that are now most interested that we're having the conversations with, it is cybersecurity. Water treatment facilities, electrical facilities, manufacturing. And I think, we're going to touch on it a little bit later, is that's a great entry point. That's a great customer. But we're still not achieving and exploiting the value of the platforms and what we can do with the ability to acquire this data that isn't related to cybersecurity.
Okay.
Let's touch more on this topic. So you start with cybersecurity, and cybersecurity is the main driver, but you see some other values and which might be even more valuable to the customers?
Absolutely. That's part of the reason we're out here too. The ability to do analytics, on complex operational, operations. The fact that we can now have visibility and collect all of the data in the industrial control environment, not just the Ethernet or the IP data, which even if you're capturing all of that, introduces a different set of challenges because that data has gone through several iterations, several systems, that it may not have the actual fidelity and provenance that you would need to have effective analytics.
Numerous surveys show that almost every manufacturer plans to invest in OT security platforms within 5 years, and more than half have already started. Leaders now tie security directly to production and profits. More than 1 in 5 organizations suffered an OT cyber incident in the past year. 40% of them caused downtime, and almost 20 took more than a month to fix. Many of these instructions were due to insecure remote access, and a small fraction of companies have advanced controls in place. These numbers explain why visibility and preparation are the top spending priorities.
In fact, we've seen lots of electronics equipment come from China with embedded command and control.
Yep.
In fact, I was just working with and talking to a controls company that was having a technical issue with a product. Turns out that product had embedded command and control into it. It's a very common brand. So that is a fact. So again, from that level of understanding, what are things that you can do to detect if that's happening in your environment or mitigate it. And so that's kind of the wholesale manufacturer as a plan says, hey, I'm going to create a product and I'm going to have embedded command and control. Again, not trying to be dystopian, but I would say, almost all of your switches, routers, network gear, there's a high probability that it has some sort of embedded command and control in it. Whether it is framed as a feature for support or not is up for debate. Then you have the other potential scenario, and that goes back to the, you can do as much as you want to the point where you've got diminishing returns. And so now maybe you have a nation state or a bad actor that goes and gets a component that it knows is in your system and modifies that to do damage. And maybe that's already in a critical infrastructure environment, waiting for, whatever the opportune time is or that they want to utilize that capability. And the reality is, we say you'll always have a 0 day. You'll always have a firmware problem. And more importantly now, you're going to have unauthorized credentialed users in your environment. It could be a rogue employee. We've seen the last couple of years kind of the sophistication of nation state and even non-nation state actors at getting into systems and stealing harvesting credentials. I can get on the dark web today and probably buy a bunch of credentials to systems. I'm going to guess 1 or 2 of them.
So you say identity management is not just an issue. I mean, currently, I would say that identity and access management is definitely in top 3 challenges because of the clouds, because of the political tension and worldwide turbulence, and because of the activity of different kinds and breeds of hackers. So you say that in ICS environment, in industrial control systems, it's also one of the top risks, the identity management, right?
Absolutely. I think in all environments. And so industrial control environments, and we talked about this earlier, you have all of those things, identity management, access controls. You have to do it. You can't not do it.
It's a fundamental of everything.
It's a fundamental. You have to do it. But there's a reality that you get to diminishing returns. On those things. You can keep pouring more and more money into it, but you're not going to make it any better. The converse to that is, and it's kind of an ugly statement, is if a person wants into your network and they have the skills, they're going to get into that network regardless of the amount of money that you've spent on all those tools. So what you're trying to do is just raise the bar. But a tragic consequence of raising the bar means that the folks that are coming at that bar probably have a lot more capability and skill than maybe you have the resources to, especially if you've got a lot of resources that you have to protect.
But if you want, raise the bar, then you allow not only for these guys, but for much less sophisticated guys also to jump over, right?
Exactly.
Right. You're diminishing the chances of being attacked because you're raising the bar and a lot of less
But you start to face more complex attacker, basically.
Yeah.
Or not, right? So the less sophisticated attackers might try to attack you, but they will not succeed, and because you have the high bar, right? And then you have a chance that the very sophisticated attackers might attack you or might not, depending on which industry you're in, what do you do, and so on.
It's just the truth, if the state actor, which doesn't have really any limitations in terms of financing and access to expertise, like Russia, North Korea, Israel, US, you name it, a couple of other countries as well. For me, it's very hard to imagine what should be the design without, redesigning completely the entire ICS with the security first in mind and security by design in mind, how we could sleep well, knowing that in fact there is no cure from this potential big threat.
Threats are changing. Foreign governments and organized crime already live inside many networks waiting for the right moment. Traditional walls, firewalls, isolated networks, and false sense of safety are not longer enough. Richard warns that overconfidence can be dangerous. He tells operators to set up tripwires everywhere so that even clever attackers set off an alarm. The goal is to see the whole picture. Ideas like zero trust, software that spots unusual behavior, and equipment built with security in mind are important, but they only work if people take them seriously. Cybersecurity is a habit. Everyone from the shop floor to the boardroom has to treat cyber risks the same way they treat safety risks. Scams using fake voices and videos, criminals renting out ransomware, and attacks on suppliers are becoming more common.
You have a Ministry of Environmental Protection, and you have a goal to exfiltrate the data in order to then use it against other ICS players, let's say. Where would you start?
I would target the weakest link or character that had the most access to the systems that I needed.
Social engineering, right?
Social engineer 101. And there's just so many ways to, that's like we always say, if someone wants to get into the system, they're going to get into the system. And there's so many creative ways and unconventional ways to get that access. So I would profile my access. I don't think the public really hears all of the detail, because typically what will happen is someone will see something, they'll call in, the cavalry, and the cavalry will say, "Everyone shut up." We've had
Which is not a bad idea.
It's not a bad idea,
speaking.
but what happens too is, so there was one particular water treatment facility that was compromised. And in looking at the compromise, we knew that we could have helped them detect that problem long time before that. Getting access to them and talking to them was impossible because of everything that insulated them. So it made, it's one of those things which seems, kind of counterintuitive, is when it happens and it's harder to help them type of thing. So, that would be kind of my example of stuff. We're publicly hearing more and more about compromised critical communications infrastructure. That's a reality. And so to me, those are the most consequential things, because that means the adversary already has access to the resource. So what should you be doing in your defense? And that's, kind of what we said. We'll put in every tool that you can to detect as early as you can. Because unless they're super sophisticated, they're going to make a mistake, or they're going to make a wrong assumption. And if you've got, like we like to say, all of your little tripwires in place, you're going to find out early. And then that goes back to the whole theme of this, is if you're just monitoring your IP communications,
you're blind. You're blind if you're not watching lower.
When AI can create perfect forgeries and hackers can reach across the world, the hum of the wire and the flicker of a sensor remain honest. That hum is our ultimate source of truth.
Reply whatever you think first. So, rapid fire. 1, 2, 3. Patch or isolate?
Both.
Detect or prevent?
Detect.
Worst ICS protocol ever?
God, they're all so good. The worst protocol ever. I don't have one.
Really?
I'm afraid to say which one it is, just because, there's a vendor that supports it. And I don't need the grief.
That's a good answer.
Let's say, is that one without proper authentication?
Well, so a lot of the industrial control protocols don't have authentication.
Yeah, but not all of them work like UDP. Without...
Correct. Yeah, without any type of...
confirmation.
Correct, that the packet got there. But sometimes that works for, depending on what you're
So there is no
accomplish.
worst ICS protocol ever. Remember that. If you had this to secure, let's say, oil refinery in 3 days, what would be your first step?
First step, one...
Cynalytica.
Well, yeah, honestly, be able to instrument and collect all of the data as part of the processes.
Collect the data.
Be able to collect the data, collect so you can detect. Everything else, like I said, is kind of a diminishing return, and you're still not getting the visibility that you need to do. But, professionally, it would be, what are their threats? What are their priorities? But yeah, the first thing is, monitor everything that you can.
Okay. If there are any ICS tool you'd never use?
Any ICS tool that I would never use?
It could be a tool, a platform, an instrument, software piece, whatever.
Pinging systems is very bad. I would never...
They still exist?
That would be the one. Stay away from ping.
Okay. What's one thing about critical infrastructure most cybersecurity pros gets completely wrong?
That their network is air-gapped.
Yeah, it's true. What's more dangerous, ignorance or outdated confidence in ICS environments?
outdated confidence always will get you. Ignorance, there's really, unless you're intentionally ignorant.
Yeah.
So I guess if it was intentional ignorance, that would be first. If it's just pure ignorance, then it's the other one.
Okay. The last one. Is a zero trust approach even possible when your system still runs Windows XP?
Yes.
Okay.
I'm not advocating running Windows XP, but this is kind of the philosophy we talked about earlier. You will always have a threat vector. You have to accept that. So what is it that you can do to mitigate what you think those threats are? So like I said, monitor and detect, understand what is bad behavior or anomalous behavior, and then know what you're going to do when you see that behavior.
Cool. Thank you very much.
Was that the right answer?
Yeah, it was a short one.
It's not ideal.
Ladies and gentlemen, Richard Robinson, CEO at Cynalytica. Thank you very much for being with us
Thank you guys.
today.
It's been awesome.
It was a pleasure.
Thank you, sir. Thank you.
Thank you. Woo!
Thank you.
We did it.